Hello everyone and welcome to the water efficiency chapter of this LEED Green Associate exam tutorial series. Now, water efficiency works like really any other LEED category, where we start with establishing our baseline and then forming a design case where we plan how we're going to meet those reductions, and then finally we end with metering to establish our progress. And we can see that if we start with a checklist. We have the three prerequisites: outdoor water use reduction, indoor water use reduction, and basic building level metering. And then for the actual credits, we reduce outdoor and indoor use beyond a certain threshold, and then using cooling towers can award 2 points, and then finally we have our building level metering. Tracking our progress is really one of the most important things that we can do in LEED. That's basically the whole point, is you have to have it on paper, you have to have the data. So let's head to the core strategies, and we see two approaches here: the water balance approach and the efficiency first approach. Now, the water balance approach is using water based on annual rainfall. Now, this could be a very sustainable method, but of course, depending on the area where the project is in, demand can exceed supply, so a building may actually have to get water from somewhere else. But overall, it's a very efficient approach. But the efficiency first approach is reducing water first and then considering the alternative methods like harvesting rainfall, water reclamation, on-site tertiary treatment. Really, this category is about minimizing water use beyond a baseline, so we have to set that baseline, and then we have the design case, which is from the baseline. The project team comes in and establishes the reduction goals and how they're going to do that. And there are a couple ways to measure this. We have flush outlets and we have flow outlets. Flush outlets, think toilets and urinals that have a certain amount of gallons per flush, so it's measured in gallons per flush. And then for flow outlets, like sinks or hoses or dishwashers, those are flow rates, which are usually used in gallons per minute. Then we have industrial fixtures that use a great deal of water use, and that's gallons per hour. Let's continue on here. We have the core strategies, and we go into the EPACT of 1992. That's not a typo, it's not EPA Act. It stands for the Energy Policy Act of 1992. That's very important to know because it's used for calculating our water use. It sets the maximum flush and flow rates, and it specifies our baseline that we're going to use for water consumption and reduction. Then we have the full-time equivalent, and this is used to calculate the number of occupants with their associated water use. So determine the FTE, and then the baseline using the flush and flow rates set in the EPACT of 1992, and then you can find the daily use. So the FTE is 1.0 for 40-hour-a-week workers. Then the flush and flow rates, as we've just discussed and given some examples. We know that per flush, it's measured per flush, and for flow outlets, it's measured in gallons per minute. We want to reduce potable water use if it's not used for drinking. Potable water is used for drinking, and it should only be used for drinking. We don't want to use it and let it go to waste. We want to treat and reclaim all gray water. Now, gray water is untreated waste that has not come into contact with toilet water, which is black water if it comes into contact with toilet water. But gray water, think bathtubs, sinks, and showers, and it can actually be treated on site with tertiary treatment if a building has the capacity to do that. Now, there are three types of water use that we're going to find: outdoor, indoor, and process use. You're probably not is familiar with process use, which is used for industrial processes, not basic human needs. So not in bathrooms or kitchens, it's used for the industrial processes. So let's head to the indoor water use. So 70% of our daily water is used indoors, and LEED requires a 20% reduction from whatever baseline is set. So once the baseline is set for indoor use, reduce it by 20%. Use high efficiency or no flush fixtures at all. Use gray water reclamation systems. Install efficient fixtures. Now, high-performance flush and flow with a water sense label, they could be 20% more efficient, and they're brought forth by the EPA to help consumers save water. So if you use these systems with a water sense label, you're probably on target to meet your 20% of reductions. Now, as for the flush and flow rates, the EPACT of 1992 set 1.6 gallons per flush for toilets and flush outlets. Well, not all flush outlets, just toilets, and 1.0 gallons per flush for urinals. So those are important numbers to know just in case they come up. We have ultra-low flow water closets as well as high-efficiency toilets that use a pressure tank for vacuum pressure. And this can reduce it to 1.28 gallons per flush, I should say. But then we have dual flush water closets, so it's mixed, a flush option for liquid and a flush option for solid waste. Ultra-low flow urinals. These can reduce flow to 0.125 using a pressure assist. But then you can also have aerators, so instead of replacing a fixture like a sink, you can put an aerator in to restrict flow by 50% mixed with air. Then we have waterless fixtures. This sounds really medieval, but we're not talking about a medieval outhouse. We're talking about systems that are designed to prevent odors and to be as sanitary as possible. Waterless urinals and composting toilets. Waterless urinals do require more maintenance, but they can save hundreds of thousands of gallons of water, and thus money. And then composting toilets can break down waste 1 to 2% of its original volume using aerobic microorganisms. Water reclamation. This is turning water like gray water or rainwater into potable water. So remember, gray water not in contact with toilet water. Rainwater, of course, is dirty, and both of these have to be treated using tertiary treatment. Hopefully it's on site, and then used for drinking. Rainwater harvesting is another good idea. It can either come from the ground or from the roof, and it can be used if it's treated for potable water, but it also can be used for flush outlets and irrigation, any other industrial processes as well. Using cooling towers, that awards 2 points if a project uses cooling towers. Gray water can be piped into buildings for flush fixtures. Reclaimed water a lot of the time does require treatment. It could also be used for fire hydrants, residential and commercial landscaping, maintaining fields, using flush outlets, using cooling towers. Then we want to install submetering because we do have to track all this progress. Water use must be monitored, especially potable water, in all buildings and grounds of a project. This can also help to detect leaks, and in the first few months a project can see 30 to 40% of reduction in use. Now this is the Prius effect, which you'll hear about in the energy and atmosphere video. Basically, if you see how well you're performing, you're going to make more steps to reducing that. And there's 1 point awarded to projects that reduce in 2 or more areas. Could be in irrigation, indoor plumbing, hot water heaters, boilers, reclaimed water systems, etc. Then we want to reduce processed water use. Now processed water use, as we said at the beginning, is used in the building's industrial sector. And we want to establish a closed loop system if we can. Basically nothing coming in, nothing coming out, just reusing that water. Now let's head into outdoor use. Now this is all water used outside, such as in irrigation, field maintenance, etc. And there are 2 popular ways to irrigate, and this is using sprinklers or drip irrigation. Now sprinklers, we know how those work. A sprinkler sprays water on the surface and it gets absorbed in the soil. But drip irrigation delivers water straight into the root, and it's much more efficient than sprinklers because it eliminates evapotranspiration. It's considered 90% more efficient, in fact. But overall, we want to make a site that reduces irrigation as much as possible. We don't want to have to water as much. So that could be done by planting adaptive and native species, as we've talked about in the Sustainable Sites video. I told you it would come back. Because these native and adaptive plants, they're already adjusted to the drought cycles, the climate. They don't need that much water, and they don't need that many pesticides. And then finally, harvest rainwater in cisterns and use non-potable water for irrigation. Basically, try to make the system as closed as possible. Don't bring new water in and don't take new water out. Just make it a closed loop. Reuse it as much as possible. Of course, we end with metering our outdoor use as well. Now, I've added a special slide for xeriscaping. Now, xeriscaping is using soil improvements, efficient irrigation, and native plants to reduce outdoor water use, which you can see here, these beautiful landscapes. This includes planning and design, the plant placement, any soil amenities, efficient irrigation, alternatives to turf, mulching, and maintenance. These are a really cool option. I've always been interested in rain gardens, which could be used on the roof or on the ground. Really reduces flooding, reduces hardscapes, as we've talked about in Sustainable Sites, and also can help restore the natural hydrology of an area. We want to reduce hardscapes and make the area as natural as possible. So that's it for this chapter. Keep going through your checklist, keep going through your sample exams and whatever book that you're using to prepare yourselves for LEED, and thank you for choosing this series.